Hello programmers, welcome to my channel Think in Java. Today we are going to discuss the factory design pattern in Java. We will discuss and implement an effective approach for this pattern and will measure the performance for both the traditional approach and the modern approach. So let's start our discussion. So you all have the basic idea about the factory design pattern. Factory design pattern is a creational design pattern which is used for the creation of the objects in Java. But you can think about it, when we have the new operator in Java for the creation of the object, then why we use this design pattern for the creation of the object? So let's understand it with the help of an example. So in this diagram, you can see that there are three parties involved for the complete creation of the objects. For example, one is the client, or you can say that user. Second is the factory, and third is the companies, or you can say that the provider which will provide the instances of the objects. So suppose user wants that I want an algorithm for implementation in my system. So user put his requirement to the factory. Factory has some kind of get algorithm method in which it provides the type of factory it wants. So suppose there are four companies in the market which provide the algorithm. One is addition, one is subtraction, another is multiplication, and fourth is the division. So when the addition, subtraction, multiplication, division companies are different, they have some common functionality also, that is common method that are defined in the interface. They all have one method which is apply algorithm, but these all companies have different kind of implementation for this method. So addition can have the different functionality for the apply algorithm. Subtraction will have the different same as the others. So when user provides suppose the multiplication to this factory, what this factory will do, this factory will call this companies, or you can say that the factory will get the particular instance of that algorithm for the implementation to the user. So let's understand it with the help of the code. We will first discuss the traditional approach, how we will create the factory in traditionally. Then after that we will discuss the modern approach, in which we will make some changes in the our algorithm factory. So this is my sample application for creating this factory design pattern. Here you can see that I have one interface, that is algorithm. The algorithm is the interface which you have seen in the example, which contains the common contract for these all algorithms. So suppose I have one method, that is apply algorithm, in this interface. Then I have my four algorithms which will implement this interface. So first is the addition algorithm, which will also implement the common functionality for the apply algorithm. The same for the division, multiplication and subtraction. These all algorithms have their implementation depending upon their requirement. So let's close all this. Now, first we will create a algorithm factory, which is our traditional approach. So what we do in the traditional approach, we take the type of the string, suppose user pass here add. Then factory will go to this method and check the if type equals to add, then returns the addition algorithm. So what it will do, it will create an instance of the addition algorithm and provide to the algorithm. So you can say that with the help of this factory, user will get the instance of algorithm and can provide or can implement the apply algorithm method. So this is our traditional approach. So you can say that if there are Suppose here is only four kind of algorithms. So if you have multiple algorithms kind of like 100 or 150 or 200, then there will be cyclomatic complexity for this if else conditions. So for removing this kind of structure, we will take a different approach to implement this factory. So now we will implement the modern design factory, or you can say that modern algorithm factory. In this design factory, I have used the enums. Enum are the very powerful in the Java. Or you can see that enum is itself a class. If you have certain kind of constants, or you can say that if you have certain kind of operations, then you can define into the enum. In the enum, you can also have their own methods and the fields. When the enum loads, there are some static methods which are already added by the compiler. For example, values of the enum. So when you call the values of the enum method at the runtime, you will get this array of all constant of the enum. So now let's go to the detail about this factory. What I have done here, I have made one kind of abstract method here, that is get algorithm, which will provide me, you can say that, different instance of my implementation algorithm. So when I make it abstract, then in my particular enum, it will force me to override this implementation. So that's why what I have done here, I have put it the override annotation to all these methods, because enum will force me to implement the functionality of that abstract algorithm. So in this particular instance, I have provided the new implementation or new instances of each algorithm depending upon their type. So let's test the code. So I have designed one sample test class for running these both to traditional and modern approach. So first we test with the help of our traditional approach. So this is our algorithm factory. I have get algorithm and I have passed the type multiplication, and then apply the algorithm with these two parameters, that is 3 and 4, and put the result into my result field. And after that I have print the result and taken the time and find the time difference to get this result. So let's run it. So you can see that we got the time in the nanoseconds, which is around I think 18,16,676 nanoseconds. So for the record, we just save this in notepad file. Now for the second approach, what we will do, we will take a map in which we will get all instances of our enum. So I have already written a map in which I have provided all kind of enum instances into the map. So now you can see that when this test class is populated, or you can say that when this test class is this test class will up, then all kind of instance of the enum will be stored in this type map. And now makes the comments the traditional approach and uncomment the modern approach. What I am doing in the modern approach, I am getting the type of the enum, that is I am passing the multiplication to the map, and the map will get the particular enum instance, or you can see that particular factory of that enum. So when I pass the multiplication, then it will get the algorithm and the apply algorithm with the parameters. Now so let's run it. and take the time. Okay, so you can see here, you can see that the time taken by the traditional approach is around 3 times the time taken by the modern approach. It is in the terms of nanoseconds, so you can say that there is nothing effect on the application. But when you talk about the product based application where the competition is very faster and very heavy, then you should do the best coding you can do. So the developer should take the best approach for implementing any kind of design pattern algorithm that he can do. So as we have seen there is a subtle difference between the both kind of approaches, and we can use the effective approach in our future coming requirements or future coming projects. So that's it from my side today. If you have any comments or any suggestions or any kind of queries, then you can put it into the comments, and then we can discuss on the another better approaches. So that's it for today. Thank you guys. If you like the video, then please share also and subscribe it also. Thank